Welcome to Alyvix. This video tutorial presents a full example showing how to build and run a complete Alyvix test case for Sales Hub, one of Microsoft's CRM applications. Hi, I'm Charles, technical writer and video tutorial lead with the Alyvix project. This video shows how you can use Alyvix to monitor the Sales Hub module within Microsoft CRM. Alyvix is a great tool for visual monitoring. It uses the existing interface of any application just as users would, in order to check that it's working properly from the user's point of view. If this is the kind of monitoring your organization needs, subscribe to our YouTube channel to get the latest updates and tutorials. To start, let's look at the run of an Alyvix test case for the Sales Hub CRM module. A single test case is designed to test a specific path through an application by clicking on buttons and filling in fields just like a user would. Alyvix uses visual recognition to check that the resulting application behavior is what was expected. Alyvix Robot can run one test case repeatedly, or run various test cases one after another to test different paths through your application. Robot then lists the elapsed time for each measured step so you can compare it with historical or expected values. Now that you've seen Alyvix Robot run through a full test case, let's build it in Alyvix Editor. Our end goal is to find availability problems or slowdowns before users do, so we want Robot to run this test case over and over again, say every 3 minutes. To build our test case, we need to show Alyvix how to find the sign-in panel and where the username field and next button are on that panel. Once we've marked those on a screen capture, we assign mouse actions and keyboard strings to those interface elements. In this same step, we can also tell Alyvix the browser executable path and give it some startup parameters like full screen and private mode. Then we make this the first step in our script and test it out right away. And now we can watch as Alyvix enters the username. Now we'll do the same thing, but with a password instead of the username. We tell Alyvix where to find the password text field, to click inside it, and then to type in the password. If this were real-world monitoring instead of a demo, we would of course encrypt our credentials. For this video tutorial, we'll just use the magic of video post-editing to hide it, but Alyvix was built to easily handle encrypted usernames and passwords. You can find out more on this topic by looking at our other videos specifically about the subject of credentials encryption here on our YouTube channel. Microsoft's Dynamics 365 will ask us if we want to stay signed in. We don't, or else we couldn't measure how long it takes to sign in each time. So we need a way to tell Alyvix that this is a quick, necessary step, but that it's not part of the test case that we really want to measure. So after we give this step a name, we'll lower the timeout to 5 seconds, and then deselect the measure field. That way we won't have so many measurements showing up the end that we have a hard time finding the most important ones. Finally, we're through to the main application screen, which consists of rows of tiles, one for each module. Since we want to test the Sales Hub module, we need to find which tile represents it. First, we check to make sure we're actually at that screen. Then we look for the Sales Hub logo plus the title to find the right tile. The rest of this step is pretty standard. Tell Alyvix to click on the tile, give it a name, and set an appropriate timeout. Here we've increased it from 10 to 20 seconds because sometimes it takes more than 10 seconds to fully load the new page. The Sales Hub module also takes a while to load completely, so we need to tell Alyvix which on-screen elements indicate that the page load has finished. It's not enough to mark the first visual elements that typically appear. We really need to point out the last ones to appear. Otherwise, we'll get a misleading picture because the application still wouldn't be usable. You can see we're starting to have a lot of steps in our script now, so it's important to give each step a meaningful name so that you can tell what it does at a glance. Now that we've arrived, we can finally start performing typical user tasks. Let's begin by opening up the Dashboards page. Here we're making selections with 2 colors, purple and green. Since the menu items can be expanded and collapsed, and these differences can persist across multiple sessions, we can't be sure that they'll always be the same distance apart. Selections with the same color must be a fixed distance away from others in that same color group, but that's not true for selections in different groups. Besides interacting with buttons and text fields, Alyvix can also operate with any other user interface element. Suppose we want to open a drop-down menu like this one and select an item. We search for the chevron symbol, which will always be to its right, but how far to the right depends on how long the item's name is. So we use the set point action to click on the name rather than on the chevron itself, since by default a click will always occur in the center of a selection. The click will open the drop-down menu, but since the menu wasn't visible when we captured this screen, we'll have to add another step where it will be visible. When we switch back to Alyvix Editor, the drop-down menu disappears, so having a few seconds before capturing the screen will give us time to reopen the menu by hand. Since Alyvix includes text recognition, we can choose an item in the menu based on the words it contains. We mark the area it might appear in, change the selections type to text, and give it a regular expression. Alyvix will then click in the center of whatever text it matches. The next step will be to check something farther down this same page, so we can save a step if we can scroll down to it now. Alyvix has a scroll action which applies a scroll movement just as if you were turning the wheel on your mouse. If you watch the test run, you'll see that it selects the menu item and then performs the scroll. Now we can check another common CRM interface element, the filter. Our scroll action from the last step has moved a big graphic into the middle of the screen. If we click on it, a filter widget will appear. We won't be able to see it until after we run this step, but it's easy to perform the click. Just select a nearby fixed object and set its click point to be in the middle of the graphic. Steps like this that just navigate through an interface without requiring a page load don't usually need to be measured. On the other hand, if it needs to make a database query, then it probably should be. Now let's put a query string into our filter and then choose the first filtered item. If you don't get your selection the right size, don't worry. You can start over with Ctrl-Z or use the mouse to resize it. Let's filter on the string quote. To put the focus on the text field, we just need to click on it. Alyvix will always do a mouse action before a keyboard action, so we don't have to worry about typing a string into the wrong component. In fact, if Alyvix can match all components in the component tree within the timeout, it will sequence all the component actions in the order they appear in the tree. This is helpful here because we need to select a value from the drop-down after we've typed our filter expression. We're getting close to the final check. Let's present the filter data as a chart, which we can do by clicking on one of the icons below the filter field, say the line chart option. When we run this step, it will filter the data and present the subset as a line chart. The CRM application in this case doesn't require much time to filter, so we won't measure it. And now our final check. To be sure that everything is loaded properly, we look for icons and labels in their correct positions. If we can make it this far down into the system, we can be reasonably sure that it's functional. And by measuring how long it took, we'll also know if the system is responsive enough. Of course, running our test case just one time in Alyvix Robot will only tell us it's working at that particular point in time. If you're going to run Alyvix Robot regularly and repeatedly using the same test case, then the state of the application at the end of that test case must match the state when it started. I mentioned earlier that we should perform every step that a user would, including launching the browser and logging in. So we also need to shut everything down, which means logging out and closing the browser. It's important to remember that steps sometimes fail, either because the application is down or because it's so slow that the timeout is exceeded. So what happens if our main script is interrupted before it finishes? Well, the logout won't take place and the browser will stay open. Then the next time Robot runs, it won't find the visual elements it's expecting, and this new run will fail. We need some way to ensure that these two steps will always run. We can do that by adding the logout step to both the main script and the fail script, which runs whenever a step exceeds its timeout value and its break flag is set. It's possible that closing the browser won't completely kill it, so we also terminate the browser process as part of the exit script, which always runs after the main script completes. To summarize, if everything goes right, then the main script executes, followed by the exit script. If instead a timeout is exceeded, then the main script stops running, the fail script begins, and finally the exit script runs. When the Alyvix Robot run concludes, it will display timing and precision data for all steps where the measurement flag was set, along with the total overall time. Alyvix provides additional output formats that can be used to send this data to monitoring applications. Thanks for watching this Alyvix video tutorial. Be sure to check out the Alyvix website, blog, and user guide at these links. And don't forget, you can also subscribe to our YouTube channel.